All right, welcome. You have reached our very last lesson in this unit. At this point, you are an expert on everything linear equation. The last thing for us to look at in this unit is on linear inequalities. Specifically, we're going to be focusing in on the graphs of linear inequalities. So that objective is pretty much what I just said, is by the end of this lesson, you can graph linear inequalities. And then similar to linear equations, we're going to see how you can apply linear inequalities to word problems. So at this point, you know what a linear equation is, but you might be wondering to yourself, what is a linear inequality? Well, a linear inequality is real similar to a linear equation, just it's an inequality instead of an equation. So pausing, linear equations, you remember, are all of those equations that we've been using this form for, slope-intercept form. So an example of a linear equation could be something like y equals 3x plus 2. That's a linear equation. The only difference for linear inequalities is instead of using an equal sign, we're going to use an inequality sign. So it could be y is greater than, it could be y is less than, y is greater than or equal to, or y is less than or equal to. Everything else, though, is still true. So even if I had a greater than sign here, this is still your slope. This is still your y-intercept. You would still graph it the same as an equation. There's just some extra stuff going on with it being an inequality. Before we get into actually graphing these, there's a couple of things I want to review real quick. When we talked about graphing just your normal inequalities, when I say normal, I'm talking about like those one variable ones, like x is greater than 2. When we talked about graphing these on a number line, there was a couple things we learned. One of the first things you learned was this idea of using an open or a closed circle, right? Something like this, it doesn't have the or equal to sign, so we would use an open circle. There's going to be something similar to that today, except instead of a circle, when you graph linear inequalities, we're graphing lines now, it's going to kind of be like an open line. The other thing we learned with graphing these is there was shading involved. We would shade left or right on the number line depending on the sign. So something like this says x is greater than 2. If it was greater than 2, we would want to show shading all numbers greater than 2. So we would shade this direction. Linear inequalities, same idea. There's going to be shading. It's just going to look different because instead of shading a number line, we're shading our graph, our coordinate plane. So we've got a spot where we're going to take down some of these notes. We said one of the first things that's different is we're going to have to, instead of choosing a circle, we're going to have to choose a line. For these symbols here, which are probably way too small for the camera, we've got the less than sign and the greater than sign. On a number line, we would use an open circle. On our coordinate plane or our graph today, we're going to use what we call a dotted line. A dotted line is going to kind of just look like a line if it was open. It's going to look something like this. That dotted line can go up, it can go down. It's going to depend on the slope, but we'll be using a line that looks like this. Now for these two, we've got less than or equal to and greater than or equal to. If it was a number line, that's where we were using our closed circle. That was the circle that was all shaded in. Same idea here, except instead of calling it a closed line, we call it a solid line. All a solid line is the normal lines you were drawing. It's a line that's all colored in. I'm talking about all this stuff with graphing them on number lines in hopes that you see how they're related, right? Open circles were like circles that weren't completely filled in. This is a line that's not completely filled in. Closed circles were circles that were colored in. This is a line that's all colored in, so they're related. The other part of graphing these linear inequalities is the shading part. So if we are trying to graph a linear inequality that uses a less than sign, could be just the less than sign or the less than or equal to sign, we want to shade everything less than the line. That would be everything below the line or everything down. So you can think of it with the word below, you can think down, you can think under the line, whichever word makes the most sense to you. But what it'll look like is if this was our line, we would want to shade everything down here. We would shade everything below the line. Even if that line went up, same idea, everything below the line. Greater than, you could probably guess then, is going to be the opposite. For greater than, you'd be shading everything above the line or everything up. That means if this right here was my line, I'd be shading everything above it. Same idea, if that line was going up, doesn't matter, I would shade everything above the line. So it's similar to what you did on graphing inequalities. It's just now going to be on a coordinate plane instead of a number line. To look at our first example, at this point, if this had been an equal sign, you already know how to graph that line. We're going to be doing all the same things for linear inequalities too. If I wanted to graph this inequality, just like with equations, we're going to start with that y-intercept. That y-intercept is at what number? At -2. So I would put my first point here at -2. And then just like with equations, I would use my slope to find more points. How would I use my slope to get to more points? Well, here that slope is -2/3. If I'm using rise over run, -2/3 means I'm going down to over 3. I've had some students ask, when that negative sign is out front like that, what does that mean? Does that mean like how I wrote it over here? Does it mean both of these need a negative? It means this or this. You can put the negative sign with the top number. You can put the negative sign with the bottom number. This does not mean, to show it does not mean, I'm going to put does not equal -2 over -3. You cannot think of it that way because negative divided by negative is positive. If this had been the fraction, then there wouldn't be a negative sign at all. So with the -2/3 slope, you can think of it either of these ways. Doesn't matter which way you think of it though. It's going to end up being points here. That's me going down 2 or over 3. Or it could be me going up to backwards 3. Up to backwards 3. They're all on the same line. Now this is where it starts to be different. If we were just graphing an equation, this is where I would draw my line and be done with it. But it's not an equation, it's an inequality. So we have 2 extra steps. Step number 1 is you've got to decide what line you want to draw. Do you want to draw a solid line or a dotted line? And then the second step is shading. We've got to decide which side of our graph we want to shade. Do we want to shade up or shade down? Let's start with the line. What line do we want to choose? Well, here this is a less than sign. Less than signs mean we want to use a dotted line. So I would come in here, oops, that doesn't look very dotted, but I would come in with a dotted line. The second part is the shading. Which way would we want to shade? Well, it's the less than sign. I want to shade everything less than the line. That would be everything below the line or down here. Now, when you're shading, you want to shade everything less than the line. So sometimes I'll see people like stop there. You don't want to stop at any axis. You want to just keep shading below the line. You want to keep going. You don't want to stop there. You want to keep shading everything below the line. Ignore, for the shading part, ignore your x and your y axis. You're just shading everything, in this case, below the line. And there you go. That's the graph. So hopefully you can see it's very similar to graphing equations. And if you're already feeling really good about equations, all we're doing is this extra part of adding in, making a line decision and then a shading decision. I've got 2 for you to try. This first one asks for you to graph y is greater than 1/4 x. For this one, the one part you want to make sure you remember, if you do not see a y-intercept, that means it must be 0. So my first point would have been here at the origin, at 0. My slope is 1/4, so I want to go up 1 over 4, up 1 over 4. I could also go down 1 backwards 4. down 1, backwards 4. I need to draw a line. I see no or equal to sign, which means it would be a dotted line. And then I want to shade. It says y is greater than. If I want to shade greater than the line, that's shading everything up here. So all of that. There's one other one. This time the question is reversed. So instead of me giving you an inequality and asking you to graph it, I'm giving you the graph and asking you to write, what mistake did I make? Write an inequality. Bad teacher. Inequality. I know it's an inequality because I see shading. That's a clue. It's going to be an inequality and not an equation. Go ahead and try that. All right. I think similar to an equation, I would still want to start off with y equals mx plus b and use that form to help me out, although I know there's not going to be an equal sign there. Looking at this, one of the first things I notice is my y-intercept is 3. That tells me that there must be a plus 3 there. I also need to figure out my slope. I've got 1 point on the line. I need another point to help me find my slope using rise over run. I could pick another point right here. My rise over run, well, rise is 1, run is 1, 2, 3. So rise over run gives me 1/3. 1/3 I can't divide, I can't simplify. That's as simple as it gets. So we get my slope is 1/3. Lots of times students forget the x, don't do that. 1/3 x. I know y is on this side. The only new part, because you've done this before with equations, but the only new part is figuring out what inequality sign you want. Similar to when we were graphing, you got to ask yourselves 2 questions. What line are they using and where is the shading? It doesn't matter the order you do it, but I'm going to start with the shading, I think. I notice the shading is above my line. That's going to tell me something. If it's above the line, then I know it's got to be a greater than sign. It can't be less than, because less than would have had all of this shaded. So I'm going to put my greater than sign. There's 2 types of greater than signs, though. There's greater than, and then there's greater than or equal to. I'm going to decide which one it is by looking at the line. Remember, if it's a dotted line, it's just a greater than sign. It's a solid line if it's greater than or equal to. So since I see that the line here is solid, that tells me the sign here should be greater than or equal to. So we got this right here is a graph of y is greater than or equal to 1/3 x plus 3. You could always, if you wanted to check this, go back and make sure it lines up. So if I wanted to graph this, I would start at 3. Okay. I'd plot more points by going up 1 over 3, up 1 over 3. There's a point. Down 1, backwards 3. There's another point. This would tell me I want a solid line. Check. And then the greater than tells me I want to shade up. Check. And so you can kind of confirm that way that you've got the right inequality. This was the first part just on graphing inequalities. Now notice that all of these inequalities had something in common. And if you're not sure what, it might be easier to see after we look at this next one here. If I'm looking at this inequality, thinking back to what you already know about graphing equations, what would I have to do in order to graph this inequality? Well, hopefully you're saying something like you can't graph it yet because we have to change this into slope-intercept form. Just like when you are graphing equations, if it's not in the form y equals mx plus b, we've got to change it around so that I can go ahead and look at it and say, that's my y-intercept, that's my slope, and then graph our line. So similar to with the equations, where sometimes you get an equation you have to change first in order to graph it, the same thing's going to be true with our linear inequalities. So looking at this one, I'm going to have to solve it first. Now it's an inequality, so think back to solving inequalities for a second. There was a rule with solving inequalities. Do you remember what that rule is? Well, the rule we had back with solving inequalities is there is something we did where you change the inequality sign. You would flip your inequality sign when you multiplied or divide by a negative number. So remember, if we had something like this and we are trying to solve for x, if I have to multiply or divide by a negative, so here I'm going to divide by -2, that means that inequality sign is going to change directions, and we get x is greater than -2 here. That same rule is going to be true even with linear inequalities. So when I'm changing that linear inequality into slope-intercept form, if I have to do that, I'm still going to need to flip my inequality sign. So looking at our inequality, I'm going to put it over here. We've got 2x minus 5y is less than or equal to 10. If I want to change it into slope-intercept form, that means I need to get y all by itself. What's the first thing we should do? Well, if I want to get y by itself, that means I need to get rid of that 2x, and I can do that since it's positive with subtracting 2x. If I subtract 2x on both sides, we get minus 5y is less than or equal to 10 minus 2x. Well, they both don't have x's, so I can't subtract them. All I can do is just copy both of them down and say 10 minus 2x. Next up, remember, I'm trying to get y by itself, so I need to get rid of that -5. -5y means -5 times y. It's multiplication. So I need to do the opposite, which is division. I need to come in and divide by -5. Now when I do that over here, that gives me y all by itself. Notice I am dividing by -5. What's going to happen? Well, I'm dividing by a negative, so that inequality sign is going to change directions. And then over here, notice I put that division all the way across 10 minus 2x because we have to divide both of them. I need to do 10 divided by -5. 10 divided by -5 is -2. And then I need to do -2x divided by -5. Sometimes it helps to break it up into parts. I need to do a negative divided by a negative. That is a positive. And I need to do 2 divided by 5. Well, 2 divided by 5, you can't do that, so we just have to write a fraction. We're going to write 2 over 5, or 2/5, and then there's an x there. So I just need to copy down my x. I did it. I got y all by itself. There's one other thing, though, you probably want to do. Remember, if our goal is to get it as y equals mx plus b, or, an inequality sign there, we want our x, our term with x first, and then the number second. So the last thing I would probably do is change the order of these. So I'm going to bring that positive 2/5 x to the front, and then put that -2 in the back so that it looks exactly like slope-intercept form. Once you've changed it around into slope-intercept form, the rest of graphing this is the same as what we did earlier. If I wanted to graph this inequality, what would I want to do? Well, I want to start at my y-intercept, which is that -2. My slope is positive 2/5, so I want to go up 2 over 5, up 2 over 5. I could also do the opposite, so I could go down 2 backwards 5, down 2 backwards 5. Because it has an or equal to sign, that tells me it needs to be a solid line. And then the last part, it's greater than or equal to. Greater than or equal to tells me I want to shade up. I want to shade greater than the line. That would be all of that there. So ta-da, we have graphed that linear inequality. I'm going to have you go ahead and try this one. The first thing I'm going to have you do is similar to our example. Go ahead and change it into slope-intercept form. If we want to change this one into slope-intercept form, you want to get y all by itself. One way you could do that is by bringing the y term over here. Then it wouldn't have these other ones with it. More commonly, though, I see students just bring both of these over here. So you could do that by adding x on both sides and adding 9 on both sides. If you do that, these cancel out, and I'm left with my 3y is less than, when I add all of this up, I've got an x, and then 0 plus 9 is 9. After that, to get y by itself, we want to divide by 3. Divide by 3 here, divide by 3 here. If I do that, I get y by itself. I'm dividing by positive 3. It's not negative, so unlike this time, I don't need to flip my inequality sign. I can just keep it as y is less than. Over here, x divided by 3. In class, that's usually where the mistake is made. Remember, there's a number in front of x. There's that number 1 there. 1 divided by 3, you can't do. It's just 1/3. So we get 1/3 x there. And then 9 divided by 3, you can do. That is 3. That is the biggest mistake, because usually the mistake I see is if students can't divide something, they just bring down the x and don't think about the fraction. But if you can't divide something like we did here, then you can't just write it. You just write it as a fraction. If I can't do 2 divided by 5, I write 2/5. If I can't do 1 divided by 3, I write 1/3. Just copy it down. It's already in sub form, which means you are ready for the second part of this question, which is describe for me what this graph would look like. All right. You should have said something like the y-intercept is at positive 3. We want our line going up 1 over 3. It should be a dotted line because there's no equal to sign, and it should be shaded below the line because it's a less than sign, something like that. There is one last part to this lesson. We said we were going to talk about how you graph linear inequalities, and then we were also going to look at how they apply to real-world situations. So we spent 2 days looking at how linear equations apply to real-world situations. This will be similar, but it's just going to incorporate more inequality signs in it. So for our first part, we've got it costs $1 to buy an apple and $2 to buy a mango. And they're asking us, write an inequality to represent how much you can buy if you have at most $10 to spend. This is a similar thing I've given to you back in Unit 1 when we were talking about inequality word problems. Go ahead and try representing this with an inequality. All right, well, I've got $1 for each apple. That means I'm paying $1 for every apple. I've got $2 for a mango. Means I'm paying $2 for every mango I want. And I've got a total of $10. There's going to be 2 variables here. One of them is how many apples I buy, and one of them is how many mangoes I buy. I could say maybe 1A, where A represents my number of apples, the number of apples I buy. So I'm paying $1 times how many apples I buy. And I'm also paying $2 for each mango. So I could say M is the number of mangoes I buy. And then I've got a total of $10. It says I can spend at most $10. Well, $10 will be on the other side here. At most $10 is an inequality. If I want to spend at most $10, it means this is the maximum I can spend. I can spend $10 or less. English is so confusing. At most, I see the word most, and you might be tempted to think, okay, most, more, greater than. At most $10 means this is the money I'm spending. I need to spend less than $10 or equal to $10. So that's our first step, is we've got our inequality here. Notice I used A and M for my number of apples and number of mangoes. You could use different variables. Remember, the letter you choose doesn't matter. Just make sure you're defining it. So you could have put the letter Z here in your inequality as long as you're telling me Z represents the apples. This was the first part of the question. There is a second part, which tells us to graph our inequality. So I'm going to erase my variables, and I'm just going to copy this here. Okay. If I wanted to graph this inequality, it's going to be similar to what we were doing in those last ones. I want to change this into a form that I know how to graph. So here I would need it to look like y equals mx plus b. Now you can leave the a and the m there if you want, but I found in class it helps a lot of students to switch them out. So instead of maybe using a for my apples because I want to eventually graph it. Maybe I want to use X for apples instead. And instead of using Y for mangoes, maybe I'll change my M to Y and say Y represents the number of mangoes. That might help you when you go to change it into a form that you're able to graph. Now that I've gone ahead and changed the X and the Y, go ahead and change this to slope-intercept form so that we can graph it. All right, the first thing you should have done, this 1 here, by the way, isn't necessary, but you can have it there if you want, is subtract your 1x on both sides. And we get 2y is less than or equal to negative 1x or negative x plus 10. And then that other step you want to do is dividing by 2. That's going to give you y is less than or equal to negative 1/2 x plus 5. Now that I've done that, I can go ahead and graph. Over here, I see the graph they've given me, but it looks a little different from what I'm used to. I'm used to having all 4 quadrants and having that y-axis keep on going, that x-axis keep on going. Why do you think they've cut it off? We've seen this before. Well, it's cut off because remember what x and y are talking about. X is the number of apples, y is the number of mangoes. Just like when we've seen this before when it's been cut off, it's cut off because you cannot have negative number of apples, you cannot have negative number of mangoes. So all we need here is this positive quadrant, this positive section of the graph. To graph though, we go through the same steps. I want to start on my y-axis at 5. It's going to be a point right here. My slope is negative 1/2, so that means I want to go down 1 over 2. Starting here, I want to go down 1 over 2 and keep doing that across my graph. I get a bunch of points. Like we learned today, I need to choose a line. This is going to be a solid line because it's got the or equal to. So I'm going to draw my solid line. Now usually you guys see me draw little arrows at the ends, but I'm not going to do that. Similar to the x and y axis, I'm not going to do that because this line isn't going to keep going on forever in both directions. It's not going to go into the negatives. So I'm just going to draw that. And then we need to shade. Well, it's a less than sign, so I'm going to shade less than the line. I'm going to shade down. So that means I'm shading all of this right here. Yeah. Because this is a real world graph, there's usually other things you see on the graph. Do you know what I'm thinking of? Well, usually with these real world graphs, there are some words on it. Usually there's like a title, and normally we need a y and an x-axis label for them. So going back to my inequality, that x, I had changed it from an a to an x because this right here represents the number of apples. So I could come in and title my x-axis number of apples. And then my y-axis, well, y was the number of mangoes. So I could come over here and say number of mangoes. For a title, I don't know what you want to title it. Fruit purchase. Fruit I can buy with $10, something like that. I'm going to call it $10 fruit purchase. Something like that. This right here would be our graph of our inequality. Now before, when we were graphing inequalities and just shading the coordinate plane, there was no story problem with it. It didn't mean as much as it does now. Here, this shaded area actually represents something with the story. There's a reason we're shading it. Do you have a guess what that shaded area represents? Well, when we were shading things on a number line, so think back to if I was shading something like x is less than 2, I was shading all the numbers that x could be. When we said x is less than 2 and we graphed it like this, that shading was showing 1, 0, -1. These are all numbers that x could be. That idea is similar to here. When we're shading this area, We are showing all the numbers that X and Y can be. Another way to think of that is we are showing all the numbers of fruit, the numbers of apples and mangoes that you can buy where your purchase is less than or equal to $10. It's just a different way of saying we're showing all the different amounts of fruits you can purchase by spending at most $10. So if I'm looking at this graph here, one point that I notice is shaded in is the point right here. I don't know if you can see that green, but I've put a point here at 1, 1. What that is telling me is I could buy 1 apple, I could buy 1 mango, and I'm not spending more money than what I've got. If I buy 1 apple, apples are $1, mangoes are $2. That means I've spent $3. I can do that if I have $10. Another point that's shaded is, let's go right here. This one is shaded. That is the point 5, 2. That point right there is shaded, and that point represents 5 apples and 2 mangoes. 5 apples, apples remember are $1, so that's $5. 2 mangoes, mangoes are $2, so 2 of them would be $4. $5 plus $4 is $9. I could do that. If I pick a point out here in this not shaded region, what do you think that means? Well, it's not shaded because it would be too much money. If I pick a point right here, that represents 11 apples and 10 mangoes. Well, if you're buying 10 mangoes, mangoes are $2 each, 10 mangoes would be $20. That's already too much money. And then once you add in the apples, that's even more money. This is something you couldn't purchase. So all of these points here in the shaded area, all of these here represent a different combination of fruits that you can buy. Now, what about the points on the line? If it's a solid line, kind of again like what we were doing with the inequalities. Let me stop using the screen because I don't think you can see it on the camera. But if we had a closed circle, remember that's the closest similarity to a solid line. A closed circle at 2 meant that X could be 2. It meant you were including it. Similar idea to this. When I've got points on a closed line, it means they're part of our solution, or they're part of the combinations you can get with $10. So for example, this point right here is on the line. That point is 4 apples and 3 mangoes. Well, 3 mangoes, $2 each, so 3 of them is $6, plus 4 apples. Apples are $1 each, so 4 apples, $4. $4 for the apples, $6 for the mangoes, $10. You can do that if you have $10. So that closed line is showing you we're also going to include any of these points here on that solid line. If it was a dotted line, that means we're not including those in the possibilities. This shaded area is always going to represent the solution for what you're talking about. Here I was talking about the number of fruit, of the different types of fruit you could purchase. That shaded area is showing you all the different fruits you can, or combination of fruits that you can buy. We've seen inequalities with money. I'm thinking back to one of our examples where it was how many cups of lemonade does she have to sell to make at least $100. Your graph might show all the different cups of lemonade she might need to sell. Maybe she's selling more than one thing, so it might show a combination of this is how many lemonade she needs to sell and this is how many water she needs to sell. But it's always going to go back to what that question is talking about. The question I would be asking here is, what can I buy with $10? That shaded area is showing you the answer to that question. This right here is the last question I've got for you guys. Thank you so much for watching this video. You are officially done with Unit 2, which is very exciting, which means tomorrow's video is going to be on a Unit 2 review. So get ready to review everything you've learned. See you guys later. Bye.